Okay, you guys, we're here again now. You guys have had your spring break already, so I hope you enjoyed it. Now we're gonna get back to math. Today, we're jumping into simplifying radicals, basically square roots. We're gonna be simplifying square roots. So that's what the topic is. Are you ready? Here we go. First thing is up here. This is super duper important. X squared, the squared terms are, 1 squared is 1, obviously. You need to have these memorized. 2 squared is 4, 3 squared 9, 4 is 16, 5, 25, 6, 36, 7, 49, 8, 64, 9, 81. 10 squared is 100, 11 squared, 121, 12 squared, 144, 13 squared, 169, 14 squared, 196. It's just 169 flipped around, and 15 squared, 225. Know those. When I say 225, you should say 15 squared. When I say 169, you should say 13 squared. You should know them like that. You're going to need to know them for simplifying radicals. It's going to be really helpful for simplifying square roots. Okay, so anyways, very important. If you don't know those, write them down, memorize them. When you're watching TV or when you're just sitting around, staying at home, or what do you call that? Home
shelter in place.
Shelter in place. So when you're sheltering in place, you could sit there and memorize those. It will be great. Okay, so here we go. Easiest thing on the face of the earth, if you know those things I just showed you. Then we're going to say, what is square root 25? That means, what number do you have to square to get 25? What number do you times by itself to get 25? If you know your squared numbers, you'll know that that is cha-ching 5, right? 121, wait a minute, that's 11 squared. So square root 121 is 11. Cha-ching, it is that easy. Do not make it harder than that. Okay, now, moving on to something a little more substantive. Here we go. It looks worse. That's only because it is worse, but it's not too bad. I even have it written right here. 64, a to the 6, b to the 10, c to the 14. Now, here's the deal. Oh my gosh, this is a perfect square number, right? 64, perfect square number. And notice, all of these powers are even. That means they divide nicely by 2. You can divide by 2 and they give you a nice integer number. So simplifying something like this is quite easy because this is a square root number and these are all even powers. Now, if this is not a square root number, or these powers are not all even, then it gets a little bit more complicated, and we'll do something like that. But right now, let's do the easier kind that has a perfect square number here and even powers. This is how easy it is. The square root of 64 is 8. Good enough. How do you take the square root of things raised to powers? Well, if it's a square root, because remember, there's always a little 2 right here. Even if it's not written, there's a little 2 there for square root. If it's a third root, you put a 3. We're not dealing with third roots today. We're only dealing with square roots. Okay, so here's how it works. It's base a to the power divided by root. So it'd be a, in fact, I'm going to write it like that, a to the 6 over 2 power. Well, that's just going to be a to the third, right? So it's a times 8 times a to the 6 over 2, which is 8 times a to the third. B to the 10th over 2 is going to make it b to the 5th. 10 divided by 2 is 5. And c to the 14 divided by 2 is just going to be c to the 7. And guess what? That's your answer. It really is that easy. I am not joking. Okay? This one, just as easy, same type of problem. Look, square root 144, you should know is 12. Good news. And look, j to the 4 divided by 2 is going to be j to the 4 divided by 2 is j squared, okay? K to the 8 divided by 2 would be K to the 4. M to the 20 divided by 2, that's M to the 10th. Cha-ching, there you go. Wait a minute. Did we just do 4 problems in a matter of seconds? Yes, we did. Nice. Okay, now we're gonna step it up just a little bit of a notch. Not a big notch, little notch. Here we go. This is one more thing we're gonna learn now. Okay, square root 98. Wait a minute. Let's go back to my squared numbers. Well, let's go back to them. Okay, watch. The squared numbers right there. 98 is not a perfect square number. Notice, 9 squared is 81. 10 squared is 100. So 98 is not a perfect square number. Well, what do? Here's what you do if it's not a perfect square number and you're trying to simplify the radical. Now, I'll tell you about what it would be. Look, if 9 squared is 81 and 10 squared is 100, then the square root of 98 would be somewhere in between 9 and 10, and 98 is a lot closer to 100. So actually 98 would be very, very close to square root of 10. It would be a little bit under square root of 100. It'd be almost 10, but a little bit under, because square root of 100 is 10. So square root of 98 would be about 9.9 something, okay? If you convert it to a decimal, but that's not what we're doing now. What we're doing now is simplifying the radical. Here's how you simplify the radical. Whenever it's not a perfect, if it is a perfect square, just simplify it like these guys. If it's not a perfect square, this is what you do. You break it into square root pretty, square root ugly. You break it into something that's pretty ugly, right? Pretty ugly. Now, what is pretty? Pretty is perfect squared numbers. Those are considered the pretty numbers, right? So like 1, 4, 9, 16, 25, 36, 49, those perfect square numbers, those are the pretty numbers. All the other numbers are ugly numbers. So what do? You find the biggest pretty number that goes into 98, okay, evenly. Well, it just so happens that 98 is 49 times 2, right? So the biggest number that goes into 98 that's a pretty number would be 49. So I put the pretty number right here. Now 49 times what gives me 98? 2. Is 2 pretty? No, it's not on our list, it's ugly. So it goes under the ugly thing. Now if you do it correctly, this is pretty, this is ugly, this will simplify, this will not, and the answer becomes 7 root 2. This simplifies to 7, this doesn't simplify, you just leave it as root 2. There you go. That's how you simplify radicals. You break them into root pretty times root ugly. Okay? Let me do another one kind of like root 98. Okay? Here we go. How about square root 75? Okay? 75. Wait a minute, let's see. 75 is not a perfect square number, okay? Because look, 75, we're at 64 and 81, right? 8 squared is 64, 9 squared is 81. So square root 75 is somewhere between 8 and 9. It's 8 point something, but we're not turning it into a decimal right now. We're gonna simplify the radical by going square root pretty and square root ugly. So there we go. Now, what's pretty about 75? Wait a minute. Wait a minute. I just remembered something. 3/4 is 75 cents. So guess what? Oh, guess what's pretty in 75? Quarters, a 25, right? And how many of them make 75 cents? 3. 3's ugly. 25 is pretty. Square root of 25 is 5, so it's 5 root 3. Cha-ching. That's how you simplify radicals if they're not perfect squares. Nice. Okay. Let's keep going. Okay, now, what about this guy? I've got it up on the big screen also. There we go, see? 200, root 200 x to the 5th, y to the 8th, z to the 7th. So, here's what we do. First of all, 200 is not a perfect square number. So, we're already in trouble. So, here's what we do though. Wait a minute, if it's not a perfect square that we could just simplify, we make it into square root pretty times square root ugly. Square root pretty, square root ugly. Cha-ching, see, like that. Okay, now, what's pretty about 200? Don't even look at these guys, right? What's pretty about 200? What's the biggest perfect square number that goes into 200? I would say 100, right? So, and you would be right if you were to say 100, right? 100 times what? What is it 100 have to times by to get 200? 2. So 100's pretty, 2 is ugly. So you put this on the pretty side, this on the ugly side. That's how it works. Okay, now x to the 5th. Wait a minute, that's an odd power. That does not divide nicely by 2. So what do? Here's what you do. You say, what is the biggest multiple of 2, which is also called the even numbers, right? What's the biggest even number that's 5 or smaller, okay? The biggest even number, the biggest multiple of 2 that is 5 or smaller would be 4. So what do? I put x to the 4 over on the pretty side, because remember, the biggest even number. Even numbers are pretty powers, odd numbers are not. And then there's 1 left over, x to the 4th here. There's 1 more x I need to get x to the 5th, so 1x goes over on the ugly side. Okay? Now, how about y to the 8th? Well, kind of like me, actually. There ain't nothing ugly about it. It's all good looking, okay? So y to the 8th goes over on this side. Ain't nothing ugly about it, okay? How about z to the 7th? Well, the biggest even number that is 7 or smaller would be 6. So I've got z to the 6th, but guess what? There's a z left over there. Okay. Now, if you did it correct, this whole thing should simplify, and this just stays root 2xz. Okay, so let's see. Root 100 is 10. X to the 4 divided by 2. Remember, there's a 2 there. 4 divided by 2 is x to the 2. Y to the 8 divided by 2 is y to the 4th. Z to the 6 divided by 2 is z to the 3rd. And then you just leave the ugly guy there. Cha-ching. That's it. Now, I know what you may be thinking. Probably the same thing I'm thinking. Wait a minute. Wait a minute. Mr. Ferrari, are you actually telling me that you think that is prettier than that? And I say, no, I don't think that actually. I think that that's prettier. But this is considered simplified, okay? Am I happy about that? Not really, okay? But that's how it is. I mean, personally, I like the looks of that better. But guess what? It's not simplified. If you want it simplified, this is it. It's considered simplified, even though that way looks a little better. Sorry. I mean, this is how you simplify radicals. Not my choice, but that's how it works. Okay. Now, let's do this one. Same exact idea on this problem. Root 45. I can flip it over to here just in case. I don't know if you'll see this or not, but there we go. So I'm going to do this. Watch. I bet you can guess. Root pretty, root ugly. Pretty and ugly. What's pretty about 45? Well, 45 is 9 times 5. So 9 is pretty because it's a perfect square. 5's ugly. It's not a perfect square. Okay. M to the 15th. The biggest even number that's 15 or smaller is 14. So I'm going to put m to the 14th on the pretty side, and then the 1m left over On the other side, we split the m to the 15 up into m to the 14 and m. M to the 12 is pretty. The whole thing's pretty. M to the 12, okay? Nothing ugly about it. P to the third, right? P squared, because that's the biggest multiple of 2 that's under 3 is squared, and then P there. So now, if we did it right, the entire side, this side will simplify, this side will not. Square root of 9 is 3. M to the 14 divided by 2 is 7. M to the 7. N to the 12 divided by 2 is n to the 6. P to the 2 divided by 2 is just p to the first power. And then it's going to be root 5mp. Okay? That is the simplified answer. That's how it is. Okay. Well, let's do it with numbers now here. Fractions, wait a minute, fractions. Yeah, here's how fractions work, no big deal. Here's the good news about fractions, simplifying radicals that have fractions under them. You can split them up this way. Look, square root of 50 over 36 is the same thing as square root 50 over square root 36. You can make it square root of the top over square root of the bottom. That's nice. Okay, and then say, wait a minute, what's even nicer, we didn't even realize it, look at the bottom, square root 36. That's just 6, nice. What is root 50? Well, root 50 is not a pretty number, so it's root pretty, root ugly, right? Bottom just stays 6. Root pretty, root ugly. What's pretty about 50? Wait a minute, 2 quarters, 50 cents, right? So 25 is pretty, 2 is ugly. So we get, here's the answer, square root of 25 is 5. So it's 5 root 2 on the top over 6 on the bottom. And that's what that simplifies to. Now, question you might be asking or thinking. Here's a point I want to make here. 5 root 2 over 6. This is the simplified answer. In fact, let me box it. Simplified answer. What some people may be asking is, hey, wait a minute. Can I cancel the 2 and the 6? Make this a 1 and this a 3, right? And the answer is no, because this 2 is underneath the square root. This 6 is not underneath the square root. So you cannot cancel the 2 and the 6. This is as simple as it gets. Okay. Let's do this one. Square root a to the 5th over 81a as a fraction. Okay, so let's get there. Okay, so here we go. It's going to be, I'm going to write it like this. Square root a to the 5th over square root 81a. I just made it square root over square root. You can do that. Okay, now the top is going to be square root pretty, square root ugly. What's pretty about a to the 5th? Well, the biggest even power that's 5 or smaller is 4. So a to the 4 is pretty. The a left over is ugly. Square root 81a. Wait a minute. That's going to be square root 81's pretty. Square root a is ugly, right? So what do we get here? I think something interesting happens here. Wait a minute, square root of a to the 4th is a to the 4 divided by 2 is a squared. Square root of 81 is 9. But wait a minute, square root a squared, wait, square root a on top and square root a on bottom, those are the same things. These are multiplications, so guess what? They do cancel. And the answer just turns out to be this. Oh my gosh, nice, nice. Great. All right. How about this one? Let's see. Square root 5x to the 10th. I'll put that on the top. Over square root 16 y to the 4th. Okay. That's going to be square root pretty, square root ugly. What's pretty about 5? 5, wait a minute, what's pretty about 5? 5 5's kind of like my brother. There ain't nothing pretty about it at all. It's just pure ugly. Right? All right. X to the 10, kind of like me. Ain't nothing ugly about it. Right? See the difference? Nice. Okay, down here, 16, root pretty, root ugly. What's pretty about 16? Everything. Okay. What's pretty about y to the 4th? Everything. Wait a minute, there's nothing ugly, is there? That is correct. So,
there's
what happens
technically
here?
a 1 there, right?
You can put a 1. Yeah, you can put a 1. Sure. Why not put a 1? That's nice. Put a 1 there. Or not. Either way. Okay, so here we go. So this is going to be x to the 5th. 10 divided by 2 times square root 5. Now I'll talk about that in just a second. And then this is going to be square root 16 is 4. Y to the 4 divided by 2 is y squared, right? And that is the answer. Now, one thing I'll just mention, this is just a little sideline thing here. Like, look, x to the 5th root 5. Wait a minute, when we're putting a number times a letter, like if we're saying 8 times x, we usually write that 8x. We usually don't write it x8. See, that looks weird. X8 looks weird to say x times 8. It's like we don't see it that. Usually we write the number first, okay? But just along these lines, notice what happens when we're using radicals. Square root 5. The radicals come at the end. Look at this. 5 root 2. Look. Blah, 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 root this. Blah, 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 root this. We always write, look at this. 5 root 3. We put numbers first. We put radicals at the end. So the conventional way of writing this is to put the root at the end. That way you know this thing is not under the root. Because if I were to put it as root 5 x to the 5th, it's like, hey, is that x to the 5th under the root or not? Well, if you write the root at the end, it's clear that this x to the 5th is not under the root. So anyways, that's the typical way of writing it. You always write the root at the end. Okay. Well, guess what? We're getting there. We're almost done, believe it or not. Just hang in there a little bit. Let me do some erasing, and we got a couple problems to go. And you guys are going to be just doing great. I think we're so excited. All right, learning some math, some simplifying, some radicals. All right, let's see. I'm so excited, I don't even remember what's next. Oh my gosh. Oh, this, I do remember. Okay, 10 root 700. 10 root 700. Okay, so far so good. Is that simplified? I don't know. The question is, obviously this 10 sitting out here, that's kind of nice. Leave the 10 there. Yay, we pulled the 10 out. But can more stuff come out still? So the question is, root pretty, root ugly. Can I break 700 into something that's pretty and ugly? Let's see. Root 700. Is there a perfect square number that goes into 700? How about 100? Okay, 100 is pretty. 7 is ugly, right? Now, square root of 100 is 10. So look what I've got here. 10 times 10 times square root 7. That's going to be 100 square root 7. Like that. 10 times that 10 times root 7. Let's do one more like that. Similar. 7x root 20. 7x root 20. Okay, well, good news. 7x is sitting outside. That's not under a radical. Yay. Root pretty, root ugly, right? What's pretty about 20? How about 4? What's ugly? 5. So 4 is pretty, 5 is ugly. Wait a minute. Now, remember, pretty guy always simplifies. Root 4 is 2. So what do we have here? 7 times x times 2 times root 5. Well, remember, we put the root at the end, and then we're going to go 7 times 2 is 14. And don't forget the x. So it's going to be 14x root 5. And that's what that simplifies to. Okay. So there you go. Oh, one more. That's right, one more. I was thinking that was the last one. There is one more. And we can't stop now. It's getting so exciting. So let's do it. Let's do this last one. Oh, it has a negative in front of it. Whoa, how does that change anything? Oh, well, you just put a negative in front of it. That's how it changes it, not much. Okay, so here we go. So we've got negative 5x, good enough. I'm not gonna mess with that. It's not under the root or anything. Root pretty, root ugly. Okay, what's pretty about 120? What's pretty about 120? 4 times 30, 4 times 30. You just gotta check it out sometimes. 4 and 30. Wait a minute, 30 has to have a pretty number inside of it. No, 5 times 6, no, 10 times 3, no. Wait, 10 has to be a pretty number. I have 10 fingers and 10 toes. No, 10 is not a pretty number. Go figure. Anyway, and then x, what's pretty about x? Nothing. It's all ugly, right? So we got 30x under the ugly side. We got 4 on the pretty side. Square root 4 is 2. So look at what we got. First of all, just keep the negative out in front. Look, negative. 5 times 2 is 10 times x times root 30x. There you go. So that's called simplifying radicals. So there you go. There's the homework number 41. Page 708, this is out of your book. 2 through 22 all, except 4 and 7. You do not have to do number 4 or number 7. Okay. Then also 32, 33, 37, 38, 45, 46, 47, 48. I picked those out purposely. I went through and picked the best ones. So there you go, your perfect homework assignment. So I will, I'll be saying bye for now, but don't worry, I'll see you again soon. And until then, stay safe and shelter inside or whatever they call it.